What is symmetric algorithm? A symmetric algorithm is a cipher used to encrypt and decrypt data using the same key. Examples of symmetric algorithms are Data Encryption Standard, DES, Triple DES, International Data Encryption Algorithm, IDEA, Advanced Encryption Standard, AES, Rivas Cipher 4, 5, and 6, and Blowfish and Twofish. With the exception of RC4, which is a stream cipher, the rest are block ciphers. Click each algorithm type to learn more. The main advantage of symmetric cryptography is that it can encrypt and decrypt data more quickly than asymmetric cryptography. This is because symmetric keys are shorter than asymmetric keys, and symmetric cryptography uses the same key to encrypt and decrypt. Symmetric cryptography works in a way that's similar to a combination lock. Imagine that Frank, Javier, and Nora all work in the same facility and all need a key to access a secure room. They all work different shifts, and the employer does not allow the key to leave the building. The employer secures the key in a lockbox with a combination code. Frank, Joe, and Nora all need the combination code to access the key and to secure the key. However, this similarity to a combination lock exposes one disadvantage of symmetric cryptography. Because you use the same key to encrypt the plaintext as you use to decrypt the ciphertext, the key must remain a secret to protect the data. How do you protect the secret key? If Alice encrypted a message for Bob, she could safely send the ciphertext. But how would she securely deliver the key? How does symmetric cryptography work? To encrypt information using symmetric cryptography, a crypto application uses a symmetric key and cipher to convert the plain text into ciphertext. In order to decrypt the ciphertext, the same symmetric key and cipher convert the ciphertext to plain text. But the problem remains, how do you securely send the key to the receiving party? What is an asymmetric algorithm? An asymmetric algorithm is a cipher used for cryptographic operations using a pair of mathematically related keys. They can do all or some of these operations: encryption, key exchange, digital signature. A key exchange operation enables two parties to safely exchange a secret or key over a public channel, such as the internet. Asymmetric algorithms and cryptography are also known as public key algorithms and cryptography. Examples of asymmetric algorithms are Diffie-Hellman, Rivas, Shamir, and Edelman, RSA, elliptic curve cryptography, ECC, pretty good privacy, PGP, and GNU Privacy Guard, GPG, and digital signing algorithm, DSA. Click each algorithm to learn more. Increased data security is the primary benefit of asymmetric cryptography. This is because users are never required to share their private keys. Asymmetric cryptography employs a pair of mathematically related keys. For encryption, the public key encrypts and the private key decrypts. Asymmetric cryptography is similar to a locking key. The lock secures the item and only the correct key can unlock the lock. The principal disadvantage of asymmetric cryptography is that the crypto processes are very slow compared to symmetric cryptography. This becomes a problem when you're streaming encrypted data between 2 points, or when you need to encrypt and decrypt large amounts of data. The slowness of asymmetric cryptography does not make it viable in these circumstances. How does asymmetric cryptography work? During the encryption process, the sender's crypto application converts the plaintext data into ciphertext using the recipient's asymmetric public key and asymmetric cipher. During the decryption process, the recipient's crypto application converts the ciphertext to plaintext using their private decryption key and the same asymmetric cipher that the sender used. The main disadvantage of symmetric encryption is securely delivering the key to the recipient, while the main disadvantage of asymmetric encryption is its slowness. When symmetric and asymmetric cryptography are combined, the disadvantages of both are remedied. Symmetric encryption uses bulk data to ensure good performance, while the symmetric key, a small piece of data, is encrypted by the recipient's public asymmetric key. Thus, the question, how do we securely send the key to the receiving party, is answered. In a scenario where the processes are combined, Alice sends an encrypted message to Bob. In the first step of encryption, Alice's crypto application generates a one-time symmetric key and, together with symmetric algorithm, encrypts the message. In the second step, the application retrieves Bob's public encryption key and uses this key, together with an asymmetric algorithm, to encrypt the symmetric key. In step 3, the encrypted message and key are sent to Bob. In the first step of decryption, Bob's crypto application retrieves the private key from its secure key store. At this stage, Bob may be required to submit credentials. The private decryption key, together with the same asymmetric algorithm that Alice used, decrypts the symmetric key. In the second step, the symmetric key together with the same symmetric algorithm that Alice used are used to decrypt the bulk data. You've completed the lesson. You can now achieve these objectives. Describe a digital key and how it is used.